Welcome to part 3, focused on thunderstorm fundamentals. We'll look at how a thunderstorm is designed, characteristics of severe storms, including clues to strong updrafts and downdrafts, along with clues that an approaching storm is getting stronger. You're presently watching the third video in this training series, representing part 3 of the training. So how is a thunderstorm designed? It has two key parts. First, it has an updraft, in which air moves upward, and a downdraft, in which air, including the storm's precipitation, descends to the surface. When the updraft gets to its maximum height where stronger flow exists, moist air within the updraft saturates and spreads downstream, forming a flat cloud called an anvil. Here are the 3 stages of the life of a thunderstorm, with each stage lasting on average 10 to 15 minutes. Eventually, precipitation forms aloft within the updraft tower and becomes heavy enough to overwhelm the updraft and fall to the surface, forming the downdraft. Eventually, the leading edge of cool downdraft air, called a gust front, it's sort of like a thunderstorm-sized cold front, it spreads out across the surface, cutting off further flow of warm, moist air into the storm's updraft, and the storm gradually weakens. Often a new storm develops in the wake of the prior one. Severe storms can last considerably longer if their precipitation falls further away from the updraft, allowing the updraft-downdraft combo to exist for a longer period of time. Severe storms can be in the form of individual storms or lines of storms called squall lines. Here you see a radar image that shows both types. Severe storms tend to have stronger updrafts and downdrafts, which are separated enough to allow the storms to last a longer period of time. Strong updrafts promote tornadoes and large hail, while strong downdrafts tend to promote damaging winds. What sky clues can you look for that tell you that you're dealing with a strong updraft? One clue is a dark, rain-free cloud base. The darker the base, the taller the storm cloud tends to be because less sunshine is able to make it through. Here's an example of a pretty dark, rain-free cloud base. When the lower part of the updraft is particularly strong, a portion of that rain-free base can extend down a bit toward the ground, producing what is called a wall cloud. Now, a signature of a strong updraft near the top of the storm is the overshooting top. Weaker updrafts spread out at the layer where the anvil forms, but more intense updrafts can bust through that layer. Here's a photo from a NASA site showing a good example. The higher the overshooting top reaches above the anvil cloud layer, the more intense the updraft tends to be near the top of the storm. An additional sign of a potentially strong low-level updraft is a stronger surface wind blowing toward the updraft. Let's say you have a day with 5 to 10 mile per hour winds. But as a storm approaches you, the wind increases to 20 to 25 miles per hour, blowing toward the storm. On rare occasions, with the strongest storms, these inflow winds can exceed 40 or 50 miles per hour. That's a sign the updraft is pulling in air from around it. You can also get a sense from how warm and moist the air is outside, and the potential for that to produce a strong updraft. Greater warmth and moisture provide more fuel to support big storms. Take a look at this amazing time-lapse video of a rapidly intensifying storm, which is being displayed as happening much faster than the naked eye obviously would observe. Nevertheless, note how clear and crisp the storm cloud is with a boiling nature to it, characteristics of a very strong updraft tower. The ascent is strong enough to prevent drier air outside of the tower from infiltrating and causing evaporation. Such evaporation is more likely with a weaker updraft that has a fuzzier appearance. Note that during the life cycle of a storm, the appearance of a strong updraft gradually evolves into the weak updraft appearance as the storm weakens. Eventually, the updraft cloud evaporates completely, leaving nothing but the anvil and decreasing precipitation. Here is your code word for this video: updraft. Be sure to write it down. Keep track of which word goes with which video. This word goes with part 3 of this training. Okay, we've looked at updrafts. What about downdrafts? Downdrafts can be weak and just associated with rain, or they can be intense and include strong wind. A particularly damaging type of downdraft is the downburst, which strikes the ground and spreads in all directions. Downbursts can be associated with 40 to 60 mile per hour wind gusts, but in some instances, the speeds can be even greater where the downburst strikes the ground. A good example of an intense downburst striking the ground and spreading out is seen on the left part of this video. Squall lines are known to produce strong downdraft winds. The term squall refers to a sudden violent burst of wind. Lines or portions of lines that move rapidly and in particular produce a bowing pattern like this seen in the radar animation is referred to as a bow echo. This can be notorious for producing damaging winds along its path. In this 15-hour radar animation, notice how fast the line of storms is moving, likely at least 60 miles an hour. As it moves across southeastern Kansas and southwestern Missouri, the line quickly bows, as the storms in the center part of the line move faster than those north and south, creating this bowing evolution on radar. If you're in the path of this type of storm pattern, it is not safe to be outdoors observing, and you should seek shelter from the approaching severe wind. There are two types of cloud features commonly associated with damaging winds, particularly with squall lines. The first is the shelf cloud. This is a low, horizontal, wedge-shaped or shelf-shaped cloud, usually near the base of a storm. It marks the gust front, this mini cold front of a thunderstorm that's along the leading edge of cooler outflow winds from the storm. The second is called a roll cloud, not quite as common as a shelf cloud is. It is a low, horizontal, tube-shaped cloud, often rotating about at a horizontal axis. It also indicates the edge of approaching outflow. Here are a few other downdraft features you might observe. The example to the right shows a rainfoot, and this is an outward deflection of the rain area near the ground as a downburst is spreading away from where it strikes the ground. So strong outflow pushes the bottom of the rain area away from the storm center. The leading edge is again the gust front, like a mini cold front generated by the storm. A similar item that's not associated with rain but rather blowing dust is called a dust foot or plume. And it's the same idea but with dust instead of rain. And you might see turbulent motion within the dusty outflow areas. Here are some clues that the environment is favorable for strong or severe thunderstorms. First, your location is within an area shown as having potential for severe storms, such as on this Storm Prediction Center graphic that outlooks where severe thunderstorms are likely. I see an example of to the right. And you can access this through our Disaster Central webpage. Secondly, if you have thunderstorms in the forecast and it's unseasonably warm and humid outside, that can be a clue. Another clue is to see cumulus clouds move quickly across the sky. This indicates strong winds above the ground, and that increasing wind with height is a favorable ingredient for severe storms. Focus on this cumulus cloud. If after 10 seconds or so it moves the distance of the small bottom arrow, that represents very slow motion due to weak winds aloft. If it moves the distance of the middle arrow, that represents more moderate flow aloft, while the top arrow represents the distance the cloud would travel due to strong flow aloft. So if the storm is moving quickly across the sky, that indicates stronger flow. That's a favorable environment condition for severe storms and tornadoes. It could be a sign of an active event to come. Here are some additional clues to look for to assess whether an approaching storm is getting stronger. First, a very dark cloud base usually relates to a very tall storm, so look for a darkening of the rain-free cloud base as a sign of an intensifying storm. Second, the amount of lightning the storm produces relates to storm height as well. Taller storms have a greater depth of charged particles that can support a greater number of lightning strikes. So when lightning and thunder increase in frequency, the storm is likely getting stronger. Likewise, if that frequency decreases, the storm may very well be getting weaker. Continuous thunder is associated with very tall, intense storms. In addition, radar imagery can be helpful for assessing changes in storm intensity. An increase in the size of area of warm colors, like orange, red, maroon, or purple, relates to a potentially intensifying storm that is producing heavier precipitation and possibly even hail. In this radar animation, Can you see areas where storms are intensifying over time and other areas where storms are changing very little over time? How would you answer this question? All of the following observations suggest an intensifying thunderstorm with a strong updraft, except for which one? Pause the video if you need more time. The correct answer is C. Heavy rain tends to be associated with a thunderstorm during its mature and weakening stages. It's not specifically a suggestion of a storm that is intensifying per se. How about this question? Here we see 3 points labeled 1, 2, and 3 for a given thunderstorm. Which points reflect the storm's updraft and downdraft? Hopefully you see the rain-free cloud base at point 2 associated with the updraft and the heavy precipitation to the right of that associated with the downdraft, so the answer would be B. You have completed part 3. If you had problems correctly answering the questions in this video or are uncertain about the material from it, you're strongly encouraged to review it again. Otherwise, please take at least a short break, then move on to the next video in this series, part 4.